Hi guys, it's Shah here at the Tech Borg, and it's been a long time since I've made a video. And the reason for that is because obviously I'm doing A-levels as well now, and it's getting a bit hectic because I'm doing A-level maths in 1 year, so it's fun as well. I mean, yeah, it's a good experience. I hope you guys are having a good time as well. But this video is going to be on maths because I guess I'm having fun with maths, so I'm doing maths, further maths, physics, economics, and no computer science, even though I want to do a degree in computer science. But yeah, okay, so let's get on with it. So this video is actually about differentiation from first principles, so how we derive the differentiation rule. It's going to be very short, so it's not going to be too hard, so let's do it. So if I just draw a graph now, okay, just draw a line. It's not the best, obviously. If I can just get this pencil. Okay, so imagine we have a curve, okay, like this. So this is terrible. Sorry, let me draw a better one here. Let's just imagine we have a curve like this, and it's called y is equal to x squared. So let's say we want to find the gradient of a tangent to a point on the curve like this point. Well, to make my life easy, I'm just going to quickly crop this bit out. Okay, this is terrible. Let me just zoom out. Okay, make this page bigger. So the point with differentiation is, sorry, it's terrible again. There we go. And so imagine we want to find the gradient between this point and this point. So let's assume that this point is h. Okay, and imagine this point is x. Sorry, not h, x plus h. Imagine the distance between this point and this point is h. Imagine in our formula, so f of x is equal to x squared, right? Okay, so that's our notation, function notation. And so this would be f of x plus h, and this would be f of x. Sorry for if you can't see it properly. Let me just draw it more thicker. Let's use this. There we go, f of x plus h, and at the bottom we have f of x, and it's very straightforward. So let's say, so how do you find the gradient of a normal line? Well, m is equal to y2 minus y1 over x2 minus x1. Okay, let me make the canvas bigger. So what we have to do is we have to okay, so we know that the y value is this, so let's plug in x plus h into the formula. So x plus h squared minus x squared over, and the value of x2 is x plus h minus x. So what we're doing essentially is we're finding the gradient of this line, yes? And if you think about it, let me just zoom into it. Let me just make another diagram and show you what I mean by this. So imagine this is the point, and this is the other point. Find the gradient of this. So the whole concept behind differentiation is you should be able to find the gradient of a point that's tangent, so only one point, not this point. So the point is, imagine that this and this had some distance h, and if you keep on reducing that distance to that much, then that much, and eventually it gets to 0. So as h approaches 0, you expect it to just fall, just like this line, and this wouldn't matter because you've traveled this distance back. So let me take you back to what we were doing. Okay, so let me zoom out of this. Okay, so we know dy over dx, which is the differentiation notation, is equal to, now we're going to look at something called limits, and limit is written as lim. Let's simplify this first, just to make our life easier. So we get x squared plus 2hx minus x squared plus h squared minus x squared, all of that over x, because the x and minus x cancel, sorry, making h. Let me just zoom out one more time and make the canvas big. There we go. Okay, let me just undo that quickly. Okay, so x squared and minus x squared cancel, and we're left with 2hx plus h squared over h, and that simplifies to 2x plus h because the h is cancelled. And so we're left with this dy over dx is equal to the limit right? So what I was saying about limit is limit is actually a function, so it represents how much a value can is going to. Let's say so in this case I told you that h is 10 towards 0, so h 10 towards 0. So a limit function is always written like this. So you have the variable, then you have the tends to, and where it goes to. So sometimes you may see lim x approaches infinity, so it might, like, this is normally seen in sequences, which I'll cover in the next video that I will put up eventually. Well, now I'm gonna continue putting up videos because I feel like in the groove of doing it, I guess you could say so. So limit as h approaches 0, and limit is a function, like I said earlier, and the most simplest way to describe them is you just enter 0 into h, so 2x plus h. Okay, and that simplifies to, I'm gonna have to make space quickly. Okay, this is a terrible rubber. Okay, you know what? I'm just gonna select this section. I think I can get rid of it. Cut. Okay, there we go. Okay, so wow, Paint has just crashed. Brilliant. So Paint just crashed and it got rid of the work. But I remember where we were at, and we were at dy over dx is equal to the limit of as h approaches 0, and in brackets we had 2x plus h. And for those of you that skipped the video and got to this point, or you can rewind back and see where I was up to. So yeah, and this is obviously for the new A levels. Sadly, we are doing the new A levels this year, 2018 May-June exams, right? So summer 2018. So as h approaches 0, so what you're literally meant to do is just put in h is equal to 0. That's what it wants you to do, 2x plus 0, and that is 2x. And for those of you that have done differentiation before in GCSE Further Maths will know the derivative of x squared, derivative also known as dy over dx. It's a noun or something, a verb, I'm not sure. So x squared simplifies to 2x, and that's the simpler way. Let me just go through that as well, because you have to know this, by the way, for A levels, how you get from first. So this is known as a derivative from first principles, differentiation from first principles. So if I quickly zoom out, I hope it doesn't glitch out like last time. Okay, let me just zoom in a little bit. Okay, so we call this differentiation in a simple way. It's just 2x. Or how? Or that 2 comes down and multiplies by the constant. So if I were to write some kind of formula, then imagine it's ax to the power of n. Well, that simplifies. Well, that becomes an to the power of x n minus 1. So the a and n multiply, and the power gets reduced by 1, and that's the simplest way to describe differentiation. Okay, let me go through a slightly harder example, something that's likely to come up in the exam, not exactly, but it's something along the lines. So they might ask you something like y is equal to minus 1 over x. So what you want to do is you want to bring the x up. So minus 1, x to the power minus 1. X to the power minus 1 is the same thing as 1 over x, and we have the minus 1 constant. So y is equal to, so if we do minus 1 times minus 1, we get 1, okay? And if we minus 1 from the minus 1, we get x to the power minus 2. And so you know that, therefore, dy over dx is equal to x, oh, sorry, my bad, 1 over x squared. That's it. Simple, isn't it? 1 over x squared, that's it. So the best solution to doing differentiation is just working through it step by step. And there are some exceptions. So if I just, again, select all of this and cut it. I hope it does not crash again, though. I genuinely hope so. Okay, it crashed again. My bad. I'm gonna make another video. So thank you for watching, and bye. I will make a video on some hard examples, but again, thank you for watching, and bye. Okay, you recovered it. Okay, no bye. Okay, so just a quick note, if you have something like x squared plus x over 2, you can't differentiate to x plus 1 because the 2 applies to the x squared and the x. So something to keep in mind, and thank you for watching, guys. I'm running out of my limit for Bandicamp. So I hope you enjoyed the video, and like, comment, subscribe, guys. Thank you.